I'll be starting the topic that is C programming. Oh, how many of you are familiar with C programming? Almost all of you. Okay, that's great. Yeah. So yours? Acha, okay, okay. No, for some branches they have Python something na, in the beginning, so that's why I have asked. Anyway, so for gate purpose, you don't have to learn how to write programs. You have to learn how to understand, read, and understand the working of a program. Then you can answer the question. And one more thing for learning programming, if you want to master programming and develop programming skills also, first you should know how to read and understand the existing programs. Then only you can develop a new program. Right. So that's a basic thing. But usually when you start programming, learn programming, you are in a hurry, right? You want to write the program by yourself. So first you finish some 100, 200 programs which are already there, understand them, then you can develop something new by yourself. So anyway, this is the basic thing. So reading and understanding. So that's why they don't have questions for writing the program. They have the questions for reading and understanding the program. How much clearly you know the topic. So under this, so we will not be starting how to write a program and all. We will not be following these steps, right? Acha, one more thing. Already I have started the classes. I have taken 3 hour session, I think, in the beginning. Just to start, I have just taken 3 hour session. So I'll be starting from the beginning once again. So there is no continuation of that. So we'll start from the beginning once again. So today in this today's session, I'll cover everything what all we have done. But in a different way, we'll be learning few more things new in this one. So let us start. See, under this C programming, what are the topics? Are you aware of the syllabus? Arrays, pointers, functions, loops, structures, right? Okay. Let us start from this one. Data types, operators, and expressions. Conditional statements, loops, or iterative statements. Then next, arrays. Sorry, structure, structure, functions. In functions, you have important thing that is parameter passing methods. In function, this is the important thing, parameter passing methods. Then pointers. Then you have recursion. And one more thing that comes along with the arrays itself. Okay, if you're copying, you can copy it here itself. That is arrays and strings. Data types and variables. These are the topics. All right. These are the topics that we have to cover under GATE syllabus. You can note down if you want to take, or you can take a snap. You can keep a snap also. That's your choice. Now, see, these are the topics. So let us explore the topics a little bit. As you said, you already know programming, you already know C programming, right? Now, if you observe in the data types and the variables. So data types and the variable means there are different scopes for the variable. That storage classes are there. Static variable, its behavior is different from other variable. Global variable, its behavior is different from normal local variable. So they ask the questions based on the static variables and global variables. That is a challenging part in this one. Static and global, right? When you talk about variables and data types. Now next, when you say data types, you can sit down. Acha, okay, no problem. So when you talk about data types, not just the range of the data type, how the data is represented in the form of bits and bytes, that is important. That is important for answering gate questions. How a integer is represented, how a negative integer is represented, how ASCII codes are given, and how the character is stored, right? So data representation is more important when it comes to data type. So I'll say bits and bytes, okay? Bits and bytes are important. Okay, let me finish. Later on, if you want, you can note down anything if you want from here. So just I'm giving you overview. So you should know about this variable and you should know about bits and bytes thoroughly. Now, when it comes to, okay, one more thing. In this, there is something called as unsigned integer. Are you aware of that? Yeah, they use that a lot. So if they use just integer, it's normal. When you use unsigned, then the behavior is different. So are you aware of it? Yeah, do you know how it works? How the result changes when you are using unsigned integer? They want to see that. They frame the question, design the question by using unsigned integer. So that is more important there. All right. Integer and float, everything you know very well, no problem. But in that, again, upon unsigned integer, when operations are performed, how they work, that is important. Now, when it comes to operators, in this operators and expression, the important operators are plus, plus, minus, minus, increment and decrement. Increment and decrement operators are important. And the next operators are bitwise operators. Whenever a question is designed using operators in gate means definitely it will be related to bitwise operators. They use bitwise operators. All right, so this topic is important in this one, bitwise operators. Now, next, conditional statement. Conditional statement is a normal thing only, but when you write the condition, when you write a condition, how C language condition works, like when you use and when you use or, what happens? What's the result in this one? That is more important. See, you know one thing important in C language, what is a true and false? Zero and non-zero. Zero is false. Any other thing is true. 5 and 9, minus 9. What is the result? X assign 5 and 9, print plus plus x. Okay, plus plus x. What is the result? 2. And result is 1. X becomes 1. Plus plus x means 2. Anyway. Now, so in this, bitwise operations are important. Now, next thing is loops. You should know the working of the loop. Like for loop is important. For loop is having 3 parts: initialization, condition, and updation. How they execute, that is more important. If you know that thoroughly, you can answer some gate questions, previous gate questions, and maybe future gate questions also. Because see, actually the gate questions are designed upon some key points. So I am showing you the key points. Okay, upon these points, they will design the question. They will not ask any simple or silly question. They will take those points where you may go wrong, the chances of giving wrong answer. They will pick up those things. So these are the key points I am just highlighting here. So in this, you have to learn about the loops. And there is something called as loop invariant. invariant. That concept we will learn. What is the condition upon which the loop will be continue running? They have asked one or more questions upon this one. So we'll discuss that point when we come to loops. Now, in this arrays, when it come to array, this is more related to pointers. They have more questions upon array along with pointers. Arrays are accessed along with pointers only. Mixed questions are there, array and pointer. Just not array of elements are given, simple things you can do. But they have used pointers also to see how you understand the code and give the answer. So this is more important. Now, again, when it comes to structure, normal structure, you know very well. But they have used pointers along with the structures. Questions are designed. Points upon the structure. The operators are different and the working is also different. Some tough questions are there upon structure using pointers. One of the difficult questions, some of the difficult questions are there using the structure. Then, in functions, parameter passing. What are the parameter passing methods are there? Call by value and call by address. Acha. Acha, if anybody is not comfortable with C, they don't know C, don't worry. We are going to learn everything. I'm just giving the list of topics that we are going to study and showing you the importance of that one. Okay. So when you are revising something, you should have these things in your mind. So in this, parameter passings are very important, right? When call by value is passed and call by address is passed, what the result? The result will vary. They will give you the code and ask you what is the output of this program. Most of the question like this only. Code is given and what is the output? All right. So they will give you parameter passing with call by value also, call by address also. So you should be able to read it perfectly and also know its behavior thoroughly. So this part is more important. Now pointers already have covered. So upon the pointers, there are various types of operations are also there. Increment, decrement of pointer and add. Subtraction of pointer is also there. Using that also, they have asked a lot of questions. Now, the important thing. If there is a gate question and operators, the code may be using recursion and operators. If there is a question upon array, the code may be using array and everywhere you will find recursion. At least function along with the parameter passing. No simple main function code is not given. They have given the code in the form of the functions only. And when the function is there, means this is there. And if they call it itself, again, recursion is there. So 60 to 70% of the C programming questions are designed using recursion only. Recursion with operators, recursion with string, recursion with arrays, recursion with parameter passing, recursion with pointers, and recursion with static variables. So now you tell me from which topic we should start. Shall we start from data types or shall we start? Because whenever we are solving any question from the topic, like when I say, when we have covered operators, I have explained the working of all the operators. When we solve PYQs, the questions are using recursion. Understood this one? And recursion, when it is there in C programming, it is there in data structures, it's there in algorithms also. So you should learn recursion in the beginning and you should continue learning it and improving your recursion part slowly. That's what the idea is. All right. So last class I have started with, those who were there, they have seen I have started with recursion only. But C programming means you should start from the data types. No. If you start from data types, some of the question like static variable, when I discuss, some questions are there using static variable and recursion. So in that, which part is difficult? No, static variable is difficult or recursion is difficult for recursion. So that's why let us make that easy, then everything becomes easy for us. That's what my idea is. Okay, let us feel comfortable with it. Otherwise, when you see the code, you get scared. Oh, what is happening here? So if you're comfortable with that, then you can understand each and everything. So that's what. So the hero of this C programming is recursion. So already I have just started and given few recursive functions, but we have to practice a lot of recursive functions using static variables, using operators, so many things we will do. So if you want to note down anything from here, you can note down. if you can note down or if you want to note down, can note down means I have just scribbled the things here and there. So here I am saying bits and bytes and static variables are important, and bits and bytes are important in this one. And these operators are important here. And in this loop, invariant is important. And for arrays structure, everything pointers are important. And here the parameter passing is important. For dynamic, that comes along with the pointers only. That comes under the topic of pointers. So for all these things, you need few basic things. You should have the clear idea of few basic things. So I have covered them. So I will cover it once again. Okay. The basic things you should have clear idea. No, recurrence relation comes under algorithms. Yeah. But you will have the idea about recurrence relation, little bit idea here itself, because some of the questions, see, if a question is there, so it's difficult to judge whether it belongs to data structure, algorithms, or C programming. Some questions are there. C code is given, now they are asking something. They ask you to write recurrence relation, so it's from algorithms. But C code is there, so it belongs to C program also. So there are few questions are there, like you can't judge. But when you cover all the subject, you can answer all the questions. Okay, shall we move ahead? Now, first of all, we understand our memory and CPU. I'm starting in a different way. So it's not revision. I'm starting freshly. Okay. We'll understand in CPU and memory part, right? So what does the CPU do? Little bit of computer organization we will discuss. Okay. Little bit of that. So what does it do? It executes the instructions. So it's having two parts. What are those? Arithmetic and logical unit and control unit. So actual operations are performed by ALU. CU will control all the components of your computer system. Right? CU will control all the components. So majorly it will control the memory. Memory. From there it will bring the data, it will send the data, or it will shuffle the data in between the registers and all. So that is the control unit. Control unit is a nervous system. Nervous system. Okay, of your computer system. And ALU is your brain, actual brain. Anyway, so all the operations or instructions are executed here. And they should be in which form? Binary form. Or we should say machine language. They should be in machine language form. The instructions must be in the machine language form. But learning machine language and writing the programs using machine language is a difficult thing for everybody to do. So when you want more and more people to learn programming and write on the program, then there should be a simple language like English so that they write the programs. And there should be some method to convert that English
Sir, your video is not coming. Sir, we can't see your video. Sir, can you hear us?
ALU and CU. Now, this should be in machine language, then only it can execute. So whatever the programs that we write, they get converted into machine language. Anyway, now let us talk about the memory.
Sir, can you repeat, please?
Memory is divided into smaller cells, and each cell is called as memory location. Each cell is called as memory location. When you say a location, so location will have its own address. So every cell is having its own address. Every cell is having its own address. So if you mark the addresses, let us say the addresses are from this is address 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9. I have not given 0, 0, 0, 1, 0, 2, 0, 3. So this becomes 1, 0, 1, 1. No, no. So that 9, then this is 10, this is 11, this is 12, this is 13, this is 14, 15, 16, so on. See, you are sitting in a two-dimensional structure, but we have to give the roll numbers. Then roll number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Roll numbers are going linear, but you are sitting in a two-dimensional fashion. So if I have to consider two-dimensional, then this is row 1, 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5. So this is two-dimensional. So I have to use x as well as y axis. But linear means just one single axis, one single axis. So these are all linear addresses. So actually you should visualize memory as a single long strip of bytes or memory locations. But we cannot visualize or understand the things properly when you draw this structure, and you have to draw a very long structure. So that's why we draw a box-like thing and understand. All right. So this is the memory. Now, this is memory, and this is called as, oh, sorry, RAM, random access memory. Why it is called as random access memory? What does it mean by random access memory? We can go to any location. Okay. Random access. So actually, now in this way, we will understand one more thing. There is something called as array. Sequential access, and one more is called as random access. If you study about files also, this is important. There are two type of files: sequential files and random access files. This is very important. So sequential access means what? See, if you have one after another, suppose you are referring a textbook and you have to go on page number 15. So you should start page number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for reaching page number 15, you have crossed 14 pages. So, and now you have to go on 25, then 16, 17, 18. Sequentially you are going. Sequentially you are going. So have you seen old tapes for audio tapes? Have you seen audio tapes in the audio player? They will insert a cassette. Now, first song will be played. After that, only second song can be played. After that, only third song can be played. If you directly want to go on third song, then you should do at least fast forward. But you should cross. So going on the pages means fast forward only. You are not reading the book in a book, but just you are going fast forward. So it's a sequential access. So sequential access means if you want to access the fifth song, you should cross 4 songs. 10th song means you should cross 9 songs. So which song can be played faster? 10th song or second song? Second. Time for playing each song is different. Means reaching to that particular song, the time is different. So that is sequential access. Sequential access. Have you seen CDs or DVDs? On that, head will be there. When you insert, head will be there. Now, in whichever location you want, it will directly go there. Have you seen this gramophone? Gramophone, have you seen this record? Playing the record. Just you place the head on whichever track you want, you can start playing that song. And every track, one song will be there. Track 1, track 0, track 1, track 2, track 3. In every track, one song will be there. Whichever song you want, just you put that head on that particular track, beginning of the track, it will go on moving, then it will start playing the song. So what is the time for reaching a particular song? Is it same or is it different? Now, for every song, the time taken is different, or just you have to put ahead. Lift ahead, third song. Lift ahead, 9 song. Lift ahead, 8 song. What's the time? Same. So reaching any location is same. That is called as random access. So this memory is random access. Suppose this address of the byte is 16, the address of this byte is, suppose this is 200, then CPU want to access this memory location or this memory location. So just it will take the address and directly it will access that particular byte. So amount of time for accessing any byte in the entire memory is same. It's not dependent on any other byte. You don't have to cross over few bytes, then only you can reach that particular byte. No, directly you can access that one. So whenever you can do that, we use the term in computer science that is random access. Okay, whenever you hear about random access, it means this. So any particular byte or any particular data item or any data item can be accessed with same amount of time. So you don't have to cross over other data to reach a particular data, right? So this memory can be directly accessed. All right. So same amount of time it will take. So you take any address. So that's why it is called as random access. Okay. This was little from the CO part I have discussed. Now, coming back to the our part. Now, in our entire C programming discussion, we will assume the size of this memory as 64 kilobytes. We'll assume the size of this memory as 64 kilobytes. So wait a minute. This is 0. And the last address is what? 65535. 64 kilo means what? 64 into kilo in computer science means 1024. So when you multiply this is 65536. So if you take the addresses, the very first address is 0, the last address is 65535. So when you say this is 64, kilo means what? Into 10 to the power of, sorry, into 2 power 10. So this is nothing but what? Okay, I'll remove this one. 64 into 2 power 10. So this 64 is what? 2 power? 2 power 6? Yeah. 2 power 6 into 2 power, 2 power 10. So this is how much? 2 power 16. And this number is very important for us. 2 power 16. Okay? 16. So this is about the memory. You can imagine any size of memory also. Nowadays, we are having memory in GBs. So that is a different story. But the basic size of the memory for studying purpose, you can go for 64 kilobytes. Okay, 64 kilobytes. Over. These figures are important. Now, do you know what is a pointer? Pointer store address. Pointer store address. So do you know pointer variable? Yes. A variable which stores the address. So where the variables are created? Here only. Here only. So it means Some locations you will use them as a pointer. Pointer means for storing the address. Understood this one? Understood this one? Now from here you have to tell me something. I want a pointer. I want a pointer to store the address of any location in the memory. So what should be the size of the pointer? 1 byte, 2 bytes, 3 bytes, or what? How much? I want a pointer which will store the address of any of these locations. So what are the addresses of the location 0, 1, 2, 3, 4, 5, 6 up to 65535? Means I want a pointer to store the address, and the addresses are from 0 to 65535. Acha, one thing. Addresses are which type? Addresses are which type? Integer type. Address is an integer only. But will it be negative also? No. So actually addresses are unsigned integers. Addresses are unsigned integer. Means pointers are actually storing what? Pointer can store only what? Unsigned integer value. But that is not data. That's an address of some location. It's not data, address of the location. So it has to store the address. So what is the minimum address? 0. What is the maximum address? 65535. So this comes in how many bytes? 16 bit. That is 2 bytes. 2 bytes. So what is the size? अब ऑन नहीं किया था मैं. हाँ, हाँ. So what is the size of the pointer in C language? 2 bytes. 2 bytes. Okay. So in our entire discussion, we will assume 2 bytes only. In a gate question, if it is more than 2 bytes, they will mention it. If they don't mention, word size of a computer, a word size of a processor, word size of a processor. I'll tell you a little bit of this one. See, word size of a processor, actually it started with 8 bits. Then it became 16 bits. Then it became 32-bit, which brought a big revolution in computer industry or IT industry. Then now presently we are using 64 bits processors. Means at a time, what is the maximum number of bits it can take for processing? Okay. So I'll give you the idea on this one. Watch it. 6 plus 9. How much? 15. Watch here, watch here. 12 plus 84. How you have done it? First you have added this, then you have added this. Okay? Sorry. 59 plus 78. You added this to carry, then you added this one along with carry you have given 159,764,254,276. I don't want answer. I don't want answer. You understood what I am explaining. So which was easiest for you? First one. So we humans can add 2 digits at a time. That's it. Not more than that. Other one, we are doing faster. Frequency is high, but we have to do it in 2 steps only. 3 is 2 steps only. And here 5, 6 steps are there. We have to take 6 steps, then only you can. Somebody can do it faster, somebody can do it slower. That is his speed. So we are not talking about the speeds. What is your capacity? Can you add these two large number at once? No, no, you can. You can't do that. You may be knowing a trick. So again, it's a speed. If you know the trick also, that is a speed. You can't add. So that's your capacity of adding two numbers. Okay, subtracting two numbers. So that's what is the capacity of the CPU at a time, what size of data it can process upon, is not in terms of decimal number system, in terms of binary number system it is. So at a time it can add two 8-bit numbers, 16-bit numbers, 32-bit numbers, 64-bit numbers. That is the word size of a processor. In one CPU cycle at once, how many numbers it can add? So it is based on bits. So it is based on the bit size. So at once it can add a 16-bit. So when we are talking about these machines, we will be referring to these machines a lot. Okay. So no doubt we are using 64-bit. So you can understand 64-bit also if you know 8-bit or 16-bit. Okay. So a little bit more more knowledge you have to gain to understand those things. But if you know basics, you can understand the other things also. So presently, we are using 64-bit processor. At a time, they can take two 64-bit size data and they can perform operations like adding, subtracting, multiplying, comparing, less than, greater than, or complement. What all the ALU operations that it can do, it can perform those operations upon 16-bit size data at a time. Sorry, 64-bit size data at a time. So we will be discussing about which type of machine. Usually when we say, we'll be talking about 16-bit machine. So that in turn refers to 32 also, 64 also. But for explaining you, see, if I take 64-bit, I should draw a bigger picture to explain you. So I can do it in smaller size picture. 8 will be too small, so it'll take 16. Understood this one? So have you heard of something called as hertz of a processor? There is a frequency with in 1 second how many instructions it can execute at a time. Like somebody gave the quick answer for this one, somebody have taken time, little bit time. So there's a frequency. So same way, some processors are slower, some processors are faster. They execute more number of instruction in 1 single second. That's a frequency. But in each instruction, what is the maximum capacity it can take? Is this one. See, byte, rice. Okay, I am taking 1 byte. This is my capacity. This is 8 bit, 16 bit, 32 bit. But now this is frequency, hertz, hertz. All right, fast. So same thing, fast. So bit size is larger also, word size is also larger, hertz is also larger. Today we are using those machines. You got this idea? Understood these things? Okay. So just we are learning basic things, so that will help us to understand. Whenever we go ahead for the further topic, this you have to keep in mind. Otherwise, I should explain all these things. Memory takes bits and bytes and 64-bit and all. So if you already know this, we'll be revising this whenever we have to come across this basics. We'll just refer this, revise this, and quickly discuss the topic. All right. Now, one more thing. Integer takes how many bytes? Huh. Actually, it depends on the word size. Integer depends on word size. So when 16-bit machines were there, integer size was 2 bytes. When 32-bit machines were introduced, then integer started taking 4 bytes in all programming languages. All basic programming languages like C, programming languages, although not scripting languages. Python is a scripting language, not a programming language. So if you talk about C, C++, Java, they take 4 bytes only. Or C sharp, J++, many languages are there. They take 4 bytes. Okay? In 32-bit machines. Earlier, they used to take 16-bit. So when you are talking about 16-bit machine, means our integer will take 2 bytes. 2 bytes. Okay? So gate questions are independent of the number of bytes. If it is dependent, they will mention whether you have to take 2 bytes or 4 bytes. They will mention in the question. If it is not mentioned in any question when you are solving, not in gate exam, in preparation, if you come across any question, if it's not there, means it's not a gate question. It's not a gate question. Okay? So they will mention how many bytes integer is taking. They will definitely mention it. Most of the questions are independent of its size. Okay? But for discussion purpose, I have to take the size. Now, is it clear? Now, do you know something about float? Do you know something about float? What is the size? 4 bytes. Always 4 bytes. Whether the machines were 60-bit or 32-bit or 64-bit. Basic size of float is 4 byte only. And if you want double and long double and all, then its size may increase. Okay, that is nothing but float only, double form of float. So basic size of a float is 4 byte only. Standard size. It's a standard size. Because every electronic device should follow the same thing only, then only you get the same numbers. Otherwise, after decimal, the numbers may change if you're using different sizes. Okay? Understood this one? That's why it's a IEEE standard, right? There is a standard. So that is followed. So all machines, electronic machine follow the same. If you have a float number on my phone, if I am sending it, so on your phone also, it will show the same thing. Okay, same number it will show. So that's why float always take 4 bytes only. See, indirectly we are learning about the data types also in this one. Anyway, now this is enough. If you want to note down anything from this, you can note down. This is important. And the pointer I have not mentioned. Yeah, pointer I have mentioned here. Pointer takes 2 bytes, and the word size also I have mentioned will be following this word size. Hmm? Hmm? अच्छा, ये ऑनलाइन क्या है ये? So do you have to reply these? So is it from the same session? What's the time? Okay, some students are attending online also, I think. Lecture online. This is our first lecture. Yeah, this is also my first lecture. It's first lecture from myself also. See, already I have started the topic in the beginning of the course. Yeah, good evening. Yeah, so I'm starting from the beginning once again. So I'm just discussing the basic concepts that are required for understanding C concepts, C programming concepts, as well as answering gate questions. So yeah, I was not aware that chat was not open. If you have any questions, you can ask. Yeah, this is from the beginning itself. Yeah, Mike was, okay. Students are attending online also. Anyway, don't worry. All these things will come across once again. So just you follow from here. From here onwards, you follow it. Okay. See, I have discussed about the memory and the RAM and the CPU, how RAM looks like. The important thing in RAM is that every byte is having its own address. Addresses are linear. And we will be assuming that the size of the RAM will be 64 kilobyte and the addresses start from 0 to 65535. And when you say RAM is of 64 kilobytes, then what's the size of the pointer that is required? So it is 2 power 16. So that is 2 bytes. Pointer size is 2 bytes. And similarly, the word size of the process is also 2 bytes. That is 16 bits. So that's how size of the integer and float is also decided. This is what I have discussed. Now let us move ahead. Huh. Now, from here, you can take it as a fresh topic. Whatever was covered, again, we may be revising it. Wherever we come across, we'll be revising it. Don't worry about that one. So let us start the next topic, the next part of basics. See, when you write any program, suppose you have written one program for, uh okay, okay. See, suppose you have written one program for adding, uh, okay, I'll write on the program, then you tell me what this program is going to do. Main, this is having some variables A, B, and C. A assign 10, B assign 5, and C assign add A comma B. Then I'm writing just print. I'm not writing complete syntax of printf. So I'll just say print C. I'm not using percentile D everything. Suppose you have written this program. It's a simple program. Just you go through this one. What this program is doing, adding two integers, adding two integers. Okay. Adding two integers. See, main function is having three variables ABC. A is having value 10, B is having value 5, and C assign ABC and print C result. So add function is called here. So this is add function, and these two values A and B values are passed into X and Y, and they are added, and the result is stored in Z, and the Z value is returned. So when you execute the main function, then here at this place add function is called, and the result is given back into C, and the C value is printed here. This is simple program. This is a simple program. Okay. Now, when you write a program, suppose you have written this program as first dot C. So this is a C language program you have written. See, when you write a program in any language, actually you will be writing text. It's like a text file only, but it will have the extension. So when you give that text file to the compiler, compiler will generate the executable file. After crossing some stages, it will prepare a executable file. So it will prepare a file called as first.exe, and that first.exe file, if you see, it will have the machine code for add function separately, and it will have the machine code for main function separately. Machine code looks like this. This is a C file, and this is a executable file, which is prepared by the compiler after converting into machine code. So when you have written two pieces as separate functions, so it will also keep them as two different pieces. It will not copy the machine code of add function in this line. It will keep it separate. It will keep it separate. All right. So add function and main function. See, now we are going to understand how our program runs in the main memory. So if you understand that, then you can understand the function calling also, then you can understand the recursion also thoroughly. And all other topics you can understand them. See, the idea here is, now what we are going to cover, the idea here is, see, as a mechanical engineer, if you have started your bike, just kick start and started a bike. Do you know what is happening inside the bike, inside the engine? All the steps? No, but you are using it. But you are using. So you are a user, you are not an engineer. When you run a program, double click and the program is running. Do you know what all has happened in the back, at the back? No. So if you don't know, then you are just a user. Just a user. If you know everything happening at the back, then you are an engineer. All right, understood this one? See, you can go to pharmacy and say that I'm feeling pain in my head or stomach. He'll give you a medicine. He's not a doctor. This medicine is for this purpose. Just say take it. So it's a user, as a user. But a doctor will diagnose and tell you what's the actual problem is, then he can give you a proper medicine. So this is the difference between just a user and an engineer, or just a consumer and a doctor. All right. So you should know how the things are working. This is very, very important. Even today, when you open any app, you should know what is happening behind. What is happening behind? What are the technologies used? What technology they might have used for developing this one? You should be able to identify it. All right. So if you are a doctor, I'm coming to you, right? Just with a lame leg, you can understand what may be the problem, isn't it? So that's how when the app is running, you should know what is the technology used. Got it? Understood this one? So at this level, you have to reach. Then you can do your own development work, your own research work beyond that. That comes after that. Anyway, so to give you that idea, I'm covering this topic now. So I'm showing you how the program runs inside. So let us continue. See, this is the C program that you have written, .c program, and compiled, and you got the machine code, and this is the machine code that is in the exe form. You have a file. Now, when you have written this program and saved it, it is saved on the hard disk, right? It is saved on the hard disk. Hard disk. So this is your first.c file. First.c file, that file. And when you have compiled, compiler will actually take this file from your hard disk, read it. If everything is perfect, syntactically everything is perfect, then it will generate the machine code for this one. If there is any error, it will show that I'm unable to understand this line. Please correct it. Okay. If everything is perfect, it will generate the machine code and it will save that file as first.exe, first.executable file. So this is the C file, this is the exe file. See, compiler works in the background. Right? Just it will say compilation completed. So actually it was reading .c file, converting into machine code, then prepared a exe file. Work is over. Behind the scene, it works behind the scene. And you have a topic on, you have a subject for compiler also. So you'll be learning how it works, all those things. Anyway, so this is ready. Now, when you want to run the program, what happens that you are going to learn now? When you want to run the program, what happens you are going to run? All right. See, when you want to run the program, see, this is the model just now we have seen. This is our memory or RAM, and this is the CPU. When you want to run the program, this first.exe, this is there on the hard disk. It cannot run directly up from the hard disk. It has to be brought into RAM. Then only CPU can access that program and execute the program. So program should be brought into RAM in main memory, in main memory. Now listen carefully. Now listen carefully. Whatever the language may be, you take from C language to Python, whatever the language is. Programs uses the memory in an organized way. They will divide the memory given to them into some sections. They divide them into sections and use them. So we assume that this program will use entire memory. Anyway, entire memory is not given to the program. A portion of the memory is kept with the operating system and maybe kept for the other applications also. But we assume that some portion, like we said that this is 64 kilobyte, and we assume that 64 kilobytes of memory entirely given to the program. So now we are going to understand how the program will divide this memory and use it. So in what section it divides. So the program, when you want to run the program, this memory is given to the program. So it will divide the memory into some sections. So I am highlighting major sections here. 3 sections I am showing. One is called as, okay, here I will write it in a different color. This is code section, code section. And after this code section, this section will be taken actually as a heap. But for explanation purpose, I will, 3 sections are there. You can call any with any name with any function, right? Any section. So I will call this as stack. This section as stack, and this section as heap. But if you see this as a memory, where is address 0? Here. Where is address 65535? Aha. So if you see it like this, then this is code section growing upwards. This is stack from higher addresses coming downwards. In between the leftover portion is heap. Actually, it's like this. So if I show heap here, stack there, I can't explain you the things properly because the diagram that is drawn will not be perfect or easy to understand. That's why I have labeled this as code section and this as a stack and this has heap. Now, where it is formed actually in the memory doesn't matter. Okay, we want to understand the working, how the program runs. Okay, now I'm going to show you how the program runs. It will divide the program into 3 sections and use it. Every program, you take Python program or C program, any program you take, it runs like that only, right? Okay. Have you heard of multi-threading? Any idea about multi-threading? Right? So each thread, all the threads will have same stack or each thread will have its own stack? Separate stack. But the heap is, does Java support multi-threading? So is it there in Java program? Python supports multi-threading? Yes or no? Yes. So it's there in the Python program also? Yes. So it's there in every programming language. Whatever the program may be, it will divide the program into 3 major sections and use it. All right. Now there is something called as a uh, segment and code segment, right? There is something, and that's a different picture. That's a different picture. So let us take this picture. All right, follow this picture. So in that, heap is not there. When you say data segment and code segment, that's the oldest picture. Now in this picture, there are three things are there. Now in this one, this is the code section, this is stack, this is heap. Now what is the use of these? What is the use of this? Let us see. When you want to run the program should be inside main memory, then only CPU can execute the program. CPU will not read the program from the file, it will read from RAM. So this machine code should be brought in RAM and or main memory and kept at some place. So where it is kept? Code section. So I will draw that. This is add function. I will draw the lines of add function, and this is main function. I'll draw the lines, machine code lines I'm showing. So the program should be brought into the main memory, into the code section, and this process is called as loading. This process is called as loading. Okay. So we have seen what we have written the program and compiled, we got the machine code. Now we are going to learn, understand how our program run. This is the main part, execution of a program. So for that, the very first thing is the program is brought into the main memory in the code section. So every program you run, it should be brought into the main memory. So if you open your phone and double click any app, so it will take time to get loaded, right? So it is brought into RAM or main memory of your phone. Then only it will appear on the screen. And CPU will start executing it. Processor will start executing it. All right. And if you have already opened it, then it's there already in the recents. So it's already there in RAM. Just you are moving from one app to another app. So large size memory is split into multiple segments, and one segment is given to each program. And that segment, it will divide into three portions and use it like this. So we are taking entire memory as a segment only. All right. So in multiple applications, it happened like this. So we are talking about the entire memory as one segment. Okay. So program is loaded. So what do you call to the process of bringing the program from the hard disk to the main memory for execution purpose? It is called as loading. Loading. Now we'll see the execution. Now we'll see the execution. Let us start. So you know very well that the program starts executing from the main function. Oh, for reading commands, I need. I, okay, I'll keep it here. I'm executing the program. Watch it. Executing the program. Integer ABC. Now program started executing. Program started executing. The very first thing. Very first thing. See, it is just like class started. So when I entered here, I'm standing here. The class is started. Then I asked for the mic. I asked for this stylus. Okay, I'll start the class. So class, I'll start the lecture. Class already started. So when I entered here and you are sitting there means class has started. After that only I'll connect the mic and I will start you. So same thing, program started. And the program is saying that I want memory for three variables. Program started, then it's asking. So the memory is allocated for these three variables. Here inside this stack, inside the stack section for those three variables. As we have already discussed that integer, we assume that it takes 2 bytes. So memory for A, memory for B, and memory for C. And this total 6 bytes of memory, let us take it as a section. And this is called as stack frame or activation record. Activation record. So there are some gate questions using this term activation records. Old gate questions are there from the old syllabus. So the memory is allocated for three variables that belong to main function. So first thing, program said that I want memory for three variables so that I can proceed further. So the memory is allocated for them. In which section? Inside stack section. And the portion of the memory that belongs to main function now is called as activation record of that particular function, activation record for that function, or it is also called as stack frame. Stack frame. It's a frame inside the stack, a portion inside the stack. Okay, so the very first line executed. So it means in machine code, what was written here? When we declare variable, what was written in the machine code? In the machine code, it was written, I want some memory. That was written there. All right, I want some memory. So memory is given to it from stack. Now the next line, A assign 10. So in this value 10 is stored. And the next line, B assign 5, value 5 is stored. The next line is calling add function. Calling add function. Next line is calling add function. So this function is called. Now you are going to learn an important thing, very important thing. This function is called. The moment this function is called, what this function is saying in this header itself, it is saying that I want X, I want Y. And the very first line inside in C programming is again declaration of variable, and it's saying that I want Z. So it is also saying that I need 3 variables. So the memory for the 3 variables, X, Y, and Z is given inside the stack, just above the memory given for main function. Above that it is given. So piled up. So the behavior is just like one above another means stack. That's why it is called as a stack. Above that. So this is the stack frame for which function? Add function. This is the stack frame for main function. This is the stack. Above that, the stack frame for add function is created. Add function is created. And if you see here, the value of A and B are passed into X and Y. So 10 and 5 are copied. Here 10 is copied and here 5 is copied. And now the very first line of add function has finished. Then the next line of add function, add these 2 values and store the result in Z. So this becomes 15. This becomes 15. Okay, just follow this one, follow this one. And the next line, return Z. So the value of Z will be returned and copied where? Inside C. So this value will be copied in this one, 15. And when it say return, whenever a function say return, it finishes, ends, terminates. And one important thing, the moment function terminates, its activation record becomes invalid. It's not erased or cleaned with a eraser or a cloth, but that becomes invalid. Invalid. All right. Suppose you are in a theater, you bought a ticket and you are sitting here. So there's your seat. Now when you go out, you are marked exit and try to come in again. No, that's not your seat. It's invalid now. Seat is there physically, right? Maybe your belongings were also there. You just went out and exit, marked exist in some place, not in a theater. Theater you can come back. When you go out of main gate, again if you are entering, now you have to buy a ticket once again. You're right? Your seat is invalid. Your seat is invalid. So that's how. Understood this one? So this memory is invalid now. Maybe 10, 5, 15 is there in the RAM. It's not cleared or made 0. It's not done. Nothing is done. All right. So this is there, but invalid. So we say that activation, for us, we say that activation record is deleted. We say activation record is deleted. All right, invalid. So we assume that it's cleared. Okay, really it's not cleared. We assume that it's cleared. So one important thing we learn that whenever the function is called, what is created? Activation record. What all the variables that are used by that function, memory is allocated for all those variables in the memory, in RAM or main memory, and the data is also filled in them. Data is also filled in them. And once the function ends, all those variables are cleared. All those variables are cleared. Understood this one? Now, when it come back to the main function, so here value is stored in C, then it will print the result C that is displayed on the screen. The value of this is finished, printed on the screen. Then the main function also ends. Usually we write return in main function also, return 0 also. It means main function ends. Even if you don't write the last statement, after the last statement, main function ends. Main function ends. And the moment main function ends, its activation record is also invalid. So we say its activation record is also deleted. Its activation record is deleted. So this is how a program runs in the memory. Now we have seen the section, code section. What will be there in the code section? Entire machine code of the program will be there. See, in our program, two functions were there. So machine code of two functions. All right. Now listen. If your program is using library function printf, then where is the machine code for printf? It's there. I'm not showing it to make it confusing, right? I'm just showing only the function that we have written. Printf is also there. So what all the functions that you are using or borrowed from the library, they are also present there. So we don't have to see those functions, just we have to see the functions we have written. So I'm showing those functions. So, right? So this is loaded in code section. And when it is executing, whatever the variables are for them, the memory is allocated here. So we have seen two sections, that is code section and stack. What about heap? How it is used, where it is used. So it's a different topic. So we'll not cover right now. We will take time for learning that one. Okay? About heap. So when we talk about heap, we have to talk about pointers also. All right? So it will take time for reaching that topic. So heap we will learn later on. So what is the important thing we have learned so far? How our program runs. So in that we have seen that program is loaded in the main memory. This was the first important thing. Okay, after compilation, program is loaded in the main memory. This is the first important thing. Second thing is when the program start executing, what all the variables it require, the activation record is created for all those variables. Okay, and whenever the function is called, activation record is created. Whenever the function terminates, it activation record is deleted. Or we will say actually I have explained you what really happens, so I have used the word invalid, but you should say deleted, created and deleted. So loading part, okay, I'm revising three sections: loading part and the creation of activation record and deletion. All right, so you can note on this one what all you have understood. Then further I'll give you some important points on this one. Any questions from online students? No, spherical. No, it's two-dimensional. Hard disk addresses are two-dimensional. It will have a sector number, track number, two-dimensional. Two addresses, two values for specifying any location. Not one address, not one value, two values are used. Heap, I have not explained. Heap I'll be covering later on. Part of add method, then how come they had the values allocated first? I'm just a little confused. No, X, Y, Z is the part of add function. They are allocated later on. They are created above. Zafar is asking the question. So first add function main function activation record is created. Above that, add function activation record is created. So that's why it is called as stack. Records are created one above another. There are no stored values in the main memory. There are no stored values in the main memory. When the program ends, everything is cleared. Execution of a program is just like a show. When the show ends, all should be cleared. Stored when No, is it similar to cache memory? No, 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 no. Don't include the terms which I have not covered. Okay, it will confuse you. I have not discussed about the cache memory, so don't consider that one. So that we will be learning in computer organization, the working of cache memory, how it works. We are talking about the main memory. Actually, our intention is to understand how our program runs inside main memory as a programmer perspective, not as a electronic person perspective. 8 out in Linux or uh, uh, no, actually, A.out is on Unix and Linux. In Windows based machines or Mac based machines, in Mac is also upon Linux now. So on Windows based machines, compiler will convert C program into exe program. It will give a exe file. But when you take a C compiler upon Linux or Unix, for every program you write, when you say compile, it will convert and generate a.out file. It will not generate for first.c, it will not generate first.exe. When you write second.c, it will convert into second.exe. But for every program, it will give you a.out file. All right. So suppose you have written one program and compiled, you got a.out. That's a machine code or ex executable code for first.c program. Now you are writing second program, another program. So this file you should rename and preserve it because always it will generate a.out. No, it's a file name. A.out is a file name. No, it's a normal file only. Instead of giving the file name as first.exe, it will give the file name as a.out. Understood? See, compiler. You put one program, first.c. Other side, it will give you first.exe file separately. Second.c, it will give you second.exe separately. Okay. Now, on Linux or Unix compiler, if you give first.c, the resultant file is, you give second.c, you give a notepad.c, you have written a complete notepad like program in C language. Now compile it. Output is a.out. That's the file name. So depending on this one, it will not give you a separate file name. It will give single file name, that is a.out. And if you want to make it as notepad.exe, then rename that file. Copy that exe somewhere else and rename it. Now next program when you compile, again that is a.out. Okay. So that is for destination, there is only one share you can say, or one channel, one location, destination. So whatever the file you give, it goes into that same only. So it will not pile up in the same file. Erase and the new program is kept there. New program is kept. No, I didn't get you. Huh. Class file or resultant file. When you want it in the resultant file, you can give different file also. Yes. Ha ha ha. Exe is the standard extension only on Windows. On other platform, exe is not based on extension. It's based on the mode of the file. यूनिक्स लिनक्स में मोड बनता है, मोड आता है, फाइल मोड आएगा. फाइल मोड एक्स 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 करेंगे तो एग्जीक्यूटेबल हो जाएगा पूरा. रीड ऑल्सो, राइट ऑल्सो, एग्जीक्यूट ऑल्सो. .exe is not there in other operating system, only on Windows. Eh, .exe belongs to only Windows. So we are talking with respect to that. Okay. Otherwise, you can say a.out. Simple. All right. It's not a.out. It's just a also. It will execute. हाँ, no need of giving dot or anything, no need of exe. exe रहा तो ही C में execute होगा. वो exe का extension file name if you change, it will say what is this, though it's executable only. So Windows operating will like, recognize the files based on the extensions. If you change the extension, it will not recognize the file. But on Unix and Linux operating system, it will recognize the file, the type of the file based on the mode of the file. It is readable, writable, and executable. Executable means it will execute. Okay, understood this one. So what was the main takeaway from this one is activation records are created and deleted. Okay, now important thing we will discuss. See, we have written the program. Oh, I'll take a yellow color. Huh. We have written the program, so let us call this as editing. And we have compiled the program. We have compiled the program. All right. Then after that, when we wanted to execute the program, first the program was, sorry, I'm writing loading. A program got loaded. Okay. Then fourth step was execution. So if you see the steps that we have seen so far, we have written the program that was editing. Then we have compiled the program and we got the machine code, executable code. Then the program was loaded. Then it was executed. These are the steps we have seen. All right. Got it? So earlier in the means a couple of weeks back when I started with this. What are the steps for writing and executing the program? But now we have done it in a different way. We have understood the working. So what are the steps we saw? Writing the program, compiling, then for running, it has to get loaded. That's also a step. Then it was executed. Okay, these are the major steps. Now, if you want to elaborate in this one, I will write on more steps. Don't copy this one, just wait. Okay, I'll give a space and write here. Editing, okay. Then second step is compiling. Then your program may be using the libraries also, right? You were talking about what happens to the library. So program will link with those libraries. It will store the information in the machine code that when I'm executing, I need these libraries. So it will link with the libraries. So that process is called as linking. You don't have to learn detail of this one. Okay, it's not relevant to the gate, and maybe it's not in other subjects also. If you want to study this one, you can study it. Something like there is something called as static linking, dynamic linking, late binding, early binding. There are some concepts. The no subject is teaching those topics because those are working in behind now. But that's interesting. If you want to study about linking, you can study this one. Then fourth step is just I am putting a list of item here. That's all. Then we have done loading. Loading. Then after that, there is one more step called as binding. Means what all the functions your program is using, it will link them or connect them so that it can call that function. It can call the function. Now, next step is execution. These are the steps that involved in writing and executing the program. All right. In this step is in our hand, and compiling, whenever you want to do compiling, you can do that. Execution is in our hand. And for execution, automatically loading happens, and linking binding also automatically happens. That's not in our hands, not in our control. Okay. These are the steps involved in writing the program. Now, one important thing, why I have listed this one, listen, very important thing. See, what all happens in these steps is called as static. What happens in this step is dynamic. There are some gate questions, you can answer them correctly if you have this clarity. If you have this clarity, you can answer these questions perfectly. What all happens in these steps is called as static. So dynamic means during execution or before execution. Only that is dynamic. Only that is dynamic. All right. And before that, what all happens is nothing but static. Static. Before execution, this is static. Up till loading, loading, binding, all these are static. Right? See, static and dynamic, till now you have heard about only compile and execution, but I have listed more steps in that one. More steps in that one. You know, only compile time, execution time, compile time, execution time. But we don't have just compile time, execution time. We have editing time, compile time, linking time, loading time, binding time, then execution time. We have different times, right? So you know only about two times: compiling and execution. But there are many different times. Yeah. Any questions online? So activation record will be given when a function is called. Yes, function, whenever a function is called, activation record is created. Yes. Binding means the address of the function is copied at the place of function call. Wherever, huh, binding means the address of a function when inside the main memory, when the function is loaded here, this is add function and this is main function. And inside the main function, you are calling add function somewhere here, suppose in this line. So the address of this add function should be copied here. That is called as binding. That is called as binding. And linking means in the exe file, just the reference to the libraries is given that this program is going to use these libraries. That is linking. But they are binded when it is loaded. So loading is done, then binding is done. Binding means writing the address of a function at the place of function call. That process is called as binding. So there is something called as early binding, there is something called as late binding, or there is something called as a static binding, there is something called as dynamic binding. Study by yourself. Okay? So it's of no use for us. So just I have given you the points, okay? As an awareness, I have just given you this one. So, Acha, have you used in any browser, have you added any toolbar, plugins, extensions, plugins? One software you have borrowed and downloaded from somewhere that is ready to run software. In that, how it can add plugins? It's just like I have two hands, right? At one time, I feel that I should have one more hand. I will buy a hand and attach. It is just like that, na? Extension or plugin. So this is created thing. In that you are adding something extra. So this is not coming from here, there. It's during lifetime it is coming. So program is running, in that you are adding a plugin. How it is possible? A binding, dynamic binding, all those things. Yeah, yeah. So just to tempt you on the topic, I have just highlighted the topic. Otherwise, I don't have to mention it here. Okay, you can explore it. It's interesting. Have you understood this one? So these are important. Now we have to go back. So actually, I have discussed about writing the program, compiling the program, loading the program, executing the program. So I have listed those things. All right. Now, actually, we have left here. Activation records are created and deleted, right? So we should know detail about the activation record now. So we are learning these things into pieces. Okay, we have seen the complete picture. Now each thing we have to explore it in detail. Now let us talk about activation record. What an activation record will contain. What an activation record will contain. See, activation record will contain space. It will contain space for variables. All right, variables. Variables are what? Parameters and local variables. Parameters as well as local variables for both the things. It will contain the space. Okay, just let me finish. Let me finish. It will be there on the board. You can note down afterwards. Okay. Contain the, it will hold the activation record will contain the space. You have already seen that. Activation record will have space for A, B, C. All right. Then next thing. Now interesting thing. Interesting thing. In your program, you have written A assign 5. Listen, listen. Just I am going a little bit detail. For A, memory is allocated. For 5, okay. A is called as variable. 5 is called as any other term? Literal. It is called as literal. Literal. Or other word, constant. Constant. Constant or literal, or else just you can simply say value. Okay. Literal means the value that you're assigning. Literal means every data type will have different type of value. So that's why you're using a term that is literal. And say constant means when you have written 5 in your program and convert to machine code, now it's always 5. It can never change. Never change. If you want to change the value, compile again. When you compile again, it's a different program. It's not the same program. New version of a program. Okay. So value remains 5 only, always 5 in the program. So that's why we are calling it as a constant also. Now my question is, variable occupy memory where that constant is stored. Are you getting me? Where the constant is stored. Now, will it be a part of an instruction itself? You know, accessing modes. Have you ever heard of this one? Immediate, direct, indirect. Have you heard this? Immediate means inside instruction. Direct means from the memory. Indirect means from the heap. Okay, I gave you the idea. Whether you have heard it or not, that's a different story. Okay. See, whenever I am asking, have you heard of this one, means you take it as a new topic only. But that details will come later. I will not assume that you know it. Okay. Just I am highlighting the point. Immediate, direct, and indirect. So this 5 we keep possibly kept inside the instruction itself, or it may also occupy the memory. So where? With no name, it's not a variable. When you say A assign 5, so this A5 is copied here. 5 is kept there and that is copied here. So for constant also, space is required in activation record. Understood this one? Let me finish. Let me finish. Understood this one? Got this? Now listen. Now listen. You have written one instruction in your program. Let us say uh, k assign 2 into 3 plus 5 into 4 minus 7. You have written something like this. Okay. You can directly write on the value, but assume that those are the variables. Those are the variables, not values, variables. So you have written an expression. Now you tell me whether this expression will be executed at once or step by step. Okay, which one do you think will execute first? This one? 6. Then added No, no. This one. So where this 6 and 20 is stored? Are you getting me? That has to be also stored somewhere. So this is the intermediate result of the expression for execution. All right. Intermediate result of the expression. Right. So that also needs space. This is 6, that is 20. Then they are added. Then that is subtracted. Right. So you need some space for storing the result of expression or intermediate result of the expression. So I'll just write, okay, I'm just scribbling here. Intermediate result of expression. Activation record will contain this. All right. So variables, parameters, and local variables, and the constants. So this depends on the compiler. We are not talking exactly about C language. In C language also, you have different versions of compilers from implementation from various vendors. So what they are following, we don't know. They may be using immediate method or they may be using direct method also. Right. So if they are using direct method, then it needs space for storing the constant. And for intermediate result of the expression also, this is required. All right. Now next. Now next. It needs space for storing. Listen, very important thing. Main is calling add. Okay, I'll give a bigger picture here. This is add function. These are the lines of add function. This is main function. And these are the lines of main function. And suppose this is the line which is calling add function. So the control goes to add. Add finishes execution. Then from here, where it should go back? It should come back to main, maybe in the same line or maybe in the next line. So whoever called the function, after execution of the function, the control should go back to the caller, go back to the caller or calling function. So we can say this is a calling function or this is a called function. So whenever a function is called, after it has finished execution, the control should go back to the calling function or caller function. Right. So but where you need its, where the control should go back, in which line the control should go back, you need an address. So that's it. You need a return address. You need a return address. These are the steps. So activation record will contain these things. It will contain the space for the variables and constants and the intermediate results of the of expression. Sorry. No, linking is not same as import. Acha, okay. Okay, you are talking about Java. Okay. So yeah, you can say it's import. When you wrote import in your .java file, then what should be there in class file? So whatever the code is written in .class file, that is called as linking. It has to refer to the library, that is linking. But execution is done, then the function must be there in the main memory and the address of should be written there to call the function. Minakshi, what was your question? Acha, okay, you are replying to some question, I think. Okay, that's great. So these are the contents of activation record. Okay. Acha, see, caller function or calling function should know the function to be called, should know the address of the function. So that address is written here, and that process is called as binding. Like you were asking what is binding. So once again, I am telling you here. Here, suppose, see, okay, let me tell again from the beginning clearly. See, now program is kept in RAM. RAM is collection of bytes. Every byte is having address. So every instruction kept in RAM is also having its address. It's also having an address. Yes. So the very first instruction address of the main function is 100, suppose. And the size of the instruction is suppose 2 bytes. So this is 102, this is 104, this is 106, sorry, 106, this is 108, this is 110, this is 112, and this is 114. Now, suppose the starting address of add function is suppose 200 onward. So this is 202, this is 204, this is 206. So at the place of add, what should be written here? 200 should be written here at the place of add. Then only when this line is executed, this line is executed, this is executed, this is so go to add function where it is at 200. So the address should be written at the place of function call. This process is called as binding. Binding. Wait a minute. So where it is written inside the machine code only, it is written. That is called as binding. Now, when the function is called and executed, it should go back, return back. So it needs returning address. So returning address is not written here in the machine code of the add function. Where it is written? Come on, come on. Activation record. It is kept inside the activation record because a function can be called by anybody. So whoever is calling, it will not modify itself here. Whoever is calling, it will keep its address inside activation record and it will go there. Now, I will summarize it. Listen, summarize it. Function called and return. Both the time you need address. Called, where the address is, where is the function is, what is the address. Return, where to go, you need the address. So for calling purpose, the address of that function is written inside the machine code of the caller function itself after loading. After loading, that's what it's called as binding. I'll give you. You brought home theater. Give you an example. You brought home theater. Home theater means main speaker, woofer, and 5-7 speakers are there. You open the box and you kept them, arranged them in the hall, in the drawing room. That is loading. That is loading. Now you connect them with cables. It is binding. Now you start the main player. It will ask, where is the speaker? It's there now connected. Go there and play it. Where is woofer? Yeah, it's connected here. So imagine it's asking where it is. So you have already linked them. So it's going and playing them. Loading means keeping all the boxes in your drawing hall or the TV hall or in your home theater, theaters. All right. Then link binding means joining the wires, joining the wires. All right. Understood. Acha. When you open the box, you will find a manual. This should be connected to this. This should be. What is this? Linking steps. Linking steps. This was done at the time of packaging, compiling part. Okay. When you purchased, you load, then execute. Load and execute. Okay. Are you able to relate it with this one? Yes. So binding need, sorry, function call needs address. And after the function ends, again it needs address for returning. So calling addresses are written inside the machine code itself. That is called as binding. But returning addresses are not written at the end of the machine of the function, but it is written inside the where? Activation record. So it will see where it has to go. Okay, he who called me? Okay, you called. I'll go there. That's it. Now this time who called me? Okay, this function called. I'll go there. And this time who called me? Because same function can be called from many other functions. All right. So it will not have just one single address here. But this function is calling add means add. There is only one add. It will call that one only. Understood this one? So you need two addresses. So you have learned in detail about the activation record also. Okay. So from this diagram, we have learned the steps, and then we saw the activation record. And the important thing in the activation record was whenever the function is called, it's created, and when the function ends, it is destroyed. Now, what is there in the activation record? I have given you all the steps. Then I have given you these steps also. I have given you the steps also. All right. Now, shall we move ahead? Hmm. Now, we will talk little bit about variables. Variables. This is a different topic. All right. See, variables will have some attributes. So I'll list the attributes first. Name of the variable, then type of the variable, then size of the variable, then value of a variable, then address of a variable, then sixth one is scope of a variable, seventh one is extent of a variable. These are the attributes of a variable or characteristics of a variable. All right. Size and type, if you combine together, there are total six. Total six. If I separate it, they are seven. So it's famously known as characteristics of variable can be defined in six tuple. Six tuple means six characteristics are there. So size and type combined together. But let us treat them separately. So I have written seven. See, in gate exam in the beginning, the one subject was there that was called as programming language. Programming language, one subject was there. Later, programming language and C. Now they made just C. They made just C. So if you refer previous gate questions, they are coming from programming language also. So we are covering programming language part. And the benefit, why we are doing it, the benefit is we get the overall picture. Even when they ask question from C language, they use the concepts of programming language. So it's not over, it's not gone. But they ask questions related to programming language. They give the C code and ask the questions of concepts of programming, because C is a programming language only, no? So that's why we are covering those concepts one by one. Instead of learning C programming, we are not learning C programming directly. All right? Hmm. Understood this? So these are the attributes of a variable. Let us understand what these are. See, the name of a variable, there are some rules that should be followed for giving the variable name in any programming language, right? Name should not start with a number, but a number can be used. It should not have special character except underscore, right? And two variables with an the variable names are case sensitive and all. These are the rules. So in C language also rules are there, right? So name will have some rule, and you are free to give any name to a variable. Now next is type, is the data type of variable. So C language is having predefined data types, or you can define your own data types. It's having predefined data types only. What are the data types? What are the data types in C language? Int, float, char. These are basic. Then you have double, that is nothing but double of the float. Basically, you have three types of variables. Okay. Then Then the next attribute of a variable is the size of the variable. So size of each data type is fixed, predefined in the compiler, or you can decide anything you like. Fixed. So what is the size of the integer? 2 or 4 bytes. Okay. So as I said that we will be following 2 bytes. Why? Because when I have to draw integer, I will draw only 2 bytes and explain you. If I draw 4 bytes, it's not easy to understand. I have to write a lot of numbers, a lot of bits. Okay, when I talk on terms of bits and bytes, it's easy. So it's 2 or 4, depends on the word size of a machine. Next is float always takes how many bytes? 4 bytes. And the character always takes just 1 byte. 1 byte. Double takes 8 bytes. That's double precision of float. Double precision of float. That's it. These are the two attributes. In general, every variable will have its name, type, and size. When it comes to C language, type and size are predefined. Now, if you want to know the range of the values in C language, then you can see that integer takes the values from, come on, minus 2676. Come on, 26768 to 26767. 26768 to 26767. Acha, that should also be 26767 only, na? Minus 26767. Why? Minus 0 is taken as 8. Huh? Um, minus 3, sorry. Can you repeat the value? Minus, oh. Yeah. Huh. Minus 3, 6, 7, 6, 8. Huh. I wrote 2. Sorry. 36768 88 oh 767 767. Yeah, see, in between you will have 0 also, and 0 will be positive also, negative also. So there is nothing like negative 0, so that negative 0 will be minus 32768. But this is a separate topic. We will see what happens inside bits, how they look like. Separately we'll cover it. Then only we can understand bitwise operations. That time I'll explain you. Now, any question? This what happened? Yeah. Minus 3 to 7 6 8 2. Is it perfect? 3 to 7 6 7. Yeah. 32 65 total. Yeah. 65535. Now float is having its own range. What is the range? Any idea? 3.4 into 10 to the power of minus 38 to plus 3.4 into 10 to the power of 38. Double is, I guess, minus 1.7 into 10 to the power of minus 308 to 1.7 into 10 to the power of 308. Now character is minus, come on, 128 to 127. Character is minus 128 to 127. All right. See, all are having negative as well as a positive, negative as well as positive. So I have covered this data types here. Yeah. Any questions From online students, any questions? Hmm. Okay. Hmm. So, coming back to this, we were here. From that, I have given you the table. Now, next is value. Depending on the data type, it can have the value. It can have the value. Or then address. Have you finished this? Huh. What is this address? In activation record, the variables are created. Just now you saw variables are created. So it will occupy memory in main memory, right? Space in main memory. It will have its address. It will have its address. So every variable during execution, it will have its address. During execution, it will have its address. Then, what is the scope and extent of a variable? What is the scope and extent of a variable? Scope and extent of a variable. Scope means visibility. Scope, telescope. Scope means visibility. Extent means expansion, lifetime. How long? What is its extent? So scope and extent, two different properties are there, two different attributes are there. Scope and extent of a variable, right? A variable will have its scope, a variable will have extent. Now one more thing. There is something called as a dynamic scope and static scope. So C language follows a static scope. All right. Extend also static and dynamic. C language follows static. Okay. So just to make you know that there is something called as a dynamic scoping also supported by other languages. Right. Just you should be aware of this one. Anyway, let us come back to C language. So based on the scope and extent of a variable, there is something called as storage classes given in C language. Storage classes, right? So there are two type of scope. Local and global. Local and global. And there is two type of extent. Let us call this also as a local and global. I'll explain you what does it mean. Follow this one. See, when you have declared a variable z inside add function, where it is visible, inside which function it is visible, only inside add. Is it visible in main? No, no. So its scope is local. Where the variable a, b, c are declared, they are declared inside main function. Are they visible inside add function? No. So their scope, visibility is local. Acha. Do you know in C language you can declare the variable here also outside the function. Then it will have a global scope. You can access anywhere you want. That is global. All right. Now, next thing. How long this XYZ will remain in the memory? As long as function is running. Once the function ends, they are deleted. Once the function is called, they are created. Function ends, they are deleted. So their lifetime is limited to the function. So that is local. Acha, what about the global variable when it is created? When the add function is called, main function is called, or independent of these functions? Independent of these functions. So what is his extent lifetime? As long as the program is running. So let us call that as global. Understood this one? So I'll repeat the point here. Scope local means variable is visible only inside the function. Scope global means variable is visible throughout the program. Extend local means variable will remain in the memory as long as the function is running. When the function ends, it is deleted. And extend global means variable will remain in the memory as long as the program is running, not the function is running. All right. So local means within a function. Local means within a function. Global means throughout the program. Throughout the program. Local means within a function. Global means throughout the program. So there are two type of scopes and extent in C language. Based on that, C language is having storage classes. C language is having storage classes. See. So what are the storage classes? Auto, static, extern, and register. So these are the classes. Then what is their scope and what is their extent? So this is local, local. This is local, global. And this is global, global. And this is again local, local. Just I have filled the box. Explanation comes next, slowly. Okay. There are 4 storage classes: auto, static, extern, register. 4 storage classes are there. Okay. And auto means scope is also local, extern is also local. Just fill up. I'll explain them. Local, 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 global, global, global. Again, last one is local, local only. So I'll explain all these one by one. No, only in C. Scope and extents, they have grouped them in the form of storage classes. They are providing in the form of storage classes. In other languages, storage classes are not there, but scope and extent is defined in some way. Scope and extent is defined. Here in C, you can mention what scope, what extent you want. It is having predefined scopes and extent. So if you say auto, then you'll get this one. If you say extern, you'll get this. It's like that. So you have option. But all are static. Nothing is dynamic. They are not dynamic. All are static only. But whether you want scope, local or global, that you can mention. In other languages, they are dynamic and they are always global. They are always local. That depends on the situation. Java is not having these storage classes. Python is not having these storage classes. This there in C and C++. Java is having a word called static, but meaning is different. It's not for storage classes. The auto is same only. No, that is where. Yeah. Auto word is used, keyword is used in C++. Yeah, keyword is used. Here we don't use it. By default, it happens. Finish. Now listen. When you declare any variable, by default, it is auto. Means it's visible only inside the function and it remains as long as the function is running. This will remain in the memory as long as add is running. This will remain in the memory as long as main is running. But actually, main is the beginning and the end of the program. So that's why it remains throughout the program. But actually, it is staying in the memory as long as main is running. That's all. Scope is also limited, local. Extend is also local. Okay. And if you declare the variables outside, that are called as which type of variable? External type of variable. So they remain throughout the program and they are visible in all the functions of a program. All right. So two storage classes I have explained. Finish. Now, what does it mean by static? What does it mean by register? A register, let us not go in detail. Little bit I'll tell you. Register means CPU will have something called as register, a space, memory. So if you declare a variable as register, then the variable will declare inside the CPU register if space is there. Otherwise, inside the main memory only. If space is there, it will go and sit there. Means a VIP section. Okay. If space is there, okay, it will go and sit there. Otherwise, it will stay in the main memory only. Okay. And the reason of using register, if you want the program to work faster in some cases, and you know that if this variable is inside CPU, it will be faster, you can do that. So that is different level of programming and different level of requirement actually. If you are clear with the requirement, then you can use that. Okay, you don't need here, and even in programming normally you don't need it, and even gate also you don't need it. Now one thing, static. What is a static? I'll explain you later. Okay, we'll move next. This is over. Now over, what is the topic we covered? Storage classes. That came from where actually? What was the major topic we were covering? We were covering the attributes of a variable. Within that, we covered the data types and their sizes. Within that only, we covered the storage classes also. Okay, we covered these two things. Over. Now, bits and bytes, we have to discuss this one. Usage, there is a lot to do. We have a lot of programs to do. We will use a static and external variable. We will do a lot of programs. Now, coming to this, to wind up this one, last thing. Now you have to tell this one. What are the times? Remember these. And among this, only this is dynamic, all are static. You have to answer some gate questions here. Old gate questions, sorry. Some gate questions. Or some questions maybe you can expect again in future also, right? They can design C questions based on this one. Now you have to answer this. The name of a variable is static or dynamic? Static. Which time you will give the name? Editing time you will give the name. Don't say compile time. Right? Always we say compile time. This vague idea we have. But now you have the clear idea now. All right? Now, in academics, we can't teach this. If I am teaching in a college, I will not show all these times and then explain. It will take 2 years for completing just one subject. So we say compile time and run time. Only two times we say. Now, for answering this, we are going in detail about this one. Now, type of a variable, data type of a variable, when it is decided, editing time only. Okay, after editing, compiler will see, acha, integer. Okay. So now you can say at the editing you wrote, but who is finalizing its type? Compiler. So you can say compiler. Both editing as well as compiler. Compiler is confirming now. This is integer, this is float, this is double. Compiler is confirming it. So you can say compile time. Or you can say editing time also, no problem. Okay. But confirm at size of a variable. 2 bytes, 4 bytes, 1 byte, 8 byte. Editing. Compile time. Compile time. Because who know the sizes? Compiler know the sizes. Yes. Compiler know the sizes. All right. Now one question I'll ask. One question. We know that in C language, some compiler take 2 bytes, some compiler take 4 byte. Unix, Linux compiler take 4 byte, and the C programming, sorry, Windows compiler takes 2 byte. DOS compiler take 2 bytes. Again, Window compiler take 4 bytes. So Now you tell me size is decided at which time? It's not in the list. It's not in the list. Can you tell me? Compiler design time or implementation time. It is done at compiler implementation time. So actually, what happened is Dennis Ritchie has given the design of C compiler. Okay, and he also implemented. Then he has said that this design is open for anybody to implement this in his own way. Follow this guideline and implement. So many people implemented C programming, C compiler. So that's why it's having multiple implementation. In his documentation, he did not mention the size of the integer. He said that you decide it by yourself based on the word size of a machine. That's why it's having different implementations. Understood? Design, he made it open, not code. Design, he made it open. So you too can follow the design and develop your own C version, C compiler implementation. And you can use your own name for it. All right. So that's how you have different versions of C. All right. Anyway, this is over. Now coming to the value. Huh. You can say long, all those things. Long you can say, and that is also a limit. Integer, if it's taking 2 bytes, long will take 4 bytes. Integer 4 byte, long will take 8 bytes. That's all. Not more than that. Huh, huh. You don't have short and byte. You have long in C, long and unsigned. Two things are there, long and unsigned. I'll show you that separately later on. You have long and unsigned are there. Anyway, see, there is no program. We have not seen any program. Just we are learning the things, okay? And we will be using them slowly as we go ahead. Now, coming back to this. So, is it static or dynamic? Static or dynamic? Static. Static or dynamic? Value? Dynamic. During runtime, it can change, right? Initially, you can have some value. That was static. Then during execution, it will change. That is dynamic. So, value is basically dynamic. Dynamic. Okay? Address of a variable decided at runtime, dynamic. So here I will say dynamic, and here I will say dynamic. Now scope of a variable, static or dynamic? Static, fixed. I already told you in C language, scope and extents are static. If you made a variable as auto, then it's local. If you made it as a static, then it's local global. So fixed. So these are all. So all the attributes are static, but these two attributes are dynamic. Okay. Run static, dynamic, static, static. Okay, very good. Okay, sir, we call. Let me check the question. Uh, okay, global, local. Okay, you are answering the question, I think. Sir, previous class you told storage classes, local variable, global variable, static register. Yes, same thing only. Global you call them external also. I wrote global that are called as external also. Yes. External and global are same thing. You can use the word external or else you can use word global. What is difference between C++ and Java? About what? In previous storage class? Same Deepak. I told local, global, and static and registered. Yes, same thing only, but global can also called as external. You can use any word of this because we don't use the keyword there. By default, they are global or by default, they are external. Anyway, design time. Acha, you are giving the answer to this one. CPU. Okay, static and dynamic. But certain type of variable also be changed at runtime conversion technique. Yeah, type of variable is not changed. It is converted and typecasted and stored in a different variable. It will be a different variable. Same variable will not be changed. Lokesh, okay, I'll answer your question separately. Huh. See, somebody asked a question online that he's saying that we can change the data type of a variable, na? Like, yeah, typecasting you can do. So it's not dynamic, he's asking. Suppose you have a variable, okay, integer x assign 65, and you have a char y, and you can say var assign char of x. So value inside x will be converted into character, so it become a and stored in y. So whose data type is changed? X becomes character from now onwards. No. No, the value is represented as character. Just value is converted. Data type of variable is not converted. The value is interpreted as character now and then stored in a character type variable. Actually, 65 only will be stored. But as the variable is a char type, printf will show it as a character when you say percentile c, so it will show a. Only picture is different on the screen. In the memory, everything is same. Print percentile d y 65. Print percentile c y a. Print percentile c x. Try this. A. Actually, in memory, it is 65. On screen, if you say percentile C, it will show character. If you say D, it will show number. Picture is different. Sir, what's the time now? Hours, hours. Okay. No, no, sir, in Roman. Oh, okay, sorry, sorry. Not that one. Picture is different. But the time is same only. Time is same only. Picture is different. Hey, sir, in Hindi. No, I don't know figures of Hindi. How you write? Acha. Something, okay, like this. Anyway, so picture will change, but the value is same. So same way, value is 65 only. Actually, characters means the picture will change on the screen, nothing else. It's a 65 only. So understood? So when you are, okay, the question was this one. When you are typecasting, you are not changing the data type of a variable. Just when you are storing the value, assigning the value, you are getting it converted in that form. Representation you are changing. If it is float, you can say int, then the value after decimal will be discarded and stored. Value is modified, not data type of variable. Anyway, all these are over. Is it clear? Shall we continue? Till what time? 9. Okay. Okay. So we have learned. Acha, I have one interesting question for you. 65 AA. 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 This is control character. See, actually it's like this. I am print. You are asking, calling me. I am printf. You are calling me. Print this value. How I should print this? Percentile. Okay, integer. I'll show integer. This is just bits and bytes for me. How you want me to show this? So you have to tell me how I should show this also. That's why in C language you have percentile C, percentile D. But whereas in Java, println, print, print X. X is which type? Integer type. So it will show integer. But C language will not have that much time to see what is the data type of that X. It will say, you tell me how you want me to show. So that's why you have to say percentile. So now you have an freedom here. So one thing you can display it in another form also. All right, you have that freedom here for printing. So control characters are there in C language. Anyway, so let us finish this topic. This is over. Now, among this, these two are dynamic. Rest of them are all static in C language. In C language. Now, going back to this, which type of variable this is based on that all the attributes of a variable, all the attributes of a variable. Scope is local, extent is local, right? All are static. Everything is static. Everything is static. But the memory is allocated at which time? Runtime. So memory allocation is dynamic. Dynamic. Understood this one? Now, one confusing part, I'm just highlighting that or raising that question. If you were asked when the memory for this variable is created, your answer would have been compile time. Today you learn something, so now you are able to say that it's happening at runtime, not at compile time. So if somebody asks you when this variable is created, your quick answer is nahi, this variable. Static or dynamic? Static. So when the memory, when the variable is created, compile time you will say. You have been saying this. See, when somebody asks which type of variable this is, static or dynamic variable. No, no, sir, this is static. So when it is created, so the compile time. So actually your answer was this, wash it. Your answer was all these attributes are decided at compile time except those. Sir, ignore those, only two. Na. So what is the type of the variable? Dynamic, static? No, no, sir, static. So when I say when it is created, you will say compile time only because most of the things are happening at compile time except memory allocation. So just one thing you leave it, sir. Value we know it is dynamic. Memory allocation is happening only at runtime. So because of that, we will not make that entire all the attribute as dynamic. So we say the term static or dynamic. I'm not asking about storage classes. I'm asking about whether it is before execution or after execution. We say variable is which type? Static type only because major number of attributes, more number of attributes are static. So your answer is compile time, compile time. That is the answer. But actually everything is not compile time. Now you know all the times clearly. Understood this one? Got it? All the different times clearly. That's all. Over. So we have finished this topic. Now we have to cover this static and external or global. Static, external and global. Okay, external or global. Now here I'm writing one program here. Oh, sorry. I'm declaring one function, and this function is having value x, having value 1, g assign g plus x, and this is main function. Inside this, I will print g. No, I will not declare this variable. This may be confusing. Just let us make it simple. I'll say just g plus plus. Print g, then call function fun, then again print g, then again say g plus plus, then again call, okay, again print g. Now, can you tell me what this code will do? This is G, variable, global variable. You declare outside. So when you declare a variable outside all the function, that will have the scope. Which scope? Where it is visible? It is visible in all the function. To whom it belongs? It doesn't belong to a particular function. It actually belongs to program. It belongs to program, entire program. So the variable is here. Hmm? Now, if you want to see how this function works, and sorry, how this program works, inside this function, G++ is done. Okay. Now, if you see the execution of the main, what happens when the execution of main is done? Print G, the value is 5. Call function fun G++. Can it change the value of G? Yes. So it will change the value to how much? 6. Now after that, this is over. Line is over. Now if you say print G, now if you see the value, that is 6. Now G++, can this function change the value? Yes, we know that this can also change the value. So this makes that 7. Then print G, what the value will be given? 7. So 567 is printed. 567 is printed. Okay. Now, my question. See, you have seen this memory model. Okay. Code section, stack, and heap. This is function fun and its machine code. And this is main and this is machine code. If main is executed, this is activation record for main is created. When function fun is called, then activation record for function fun is created. I don't have any variables here. Okay, I wrote the program simple. Suppose some variables are there that are created here. Some variables are there, they are created here. Okay, you know this one. So this portion is nothing but what? Stack. Now listen, my question is coming here. My question is coming here. If this is having any variable, they are created in its own activation record. If this is having any variable, this is created in its own activation record. Now the question is where this variable G is created. This doesn't belong to function. This doesn't belong to main. So this belongs to program. So definitely this is created inside what? Code section. This is created in code section. So in C language, there is one more thin separate section. In C language, there is one more section called as, this section is called as global and static variable section. So total how many sections are there? 4. Okay, I'll do one thing. Code, no, wait a minute. Code section, stack, heap. 1, 2, 3, 4. There are total 4 sections as per C language. Listen, let me finish this one. As per C language. Now, how this function, how this section is, C heap, I said we'll cover later. Stack, I have shown you it's working. It's only for activation records. Code section is for dumping the code. Then how this function is? Actually, it is same as a code section only, just for dumping the variables. Code is dumped here, variables are dumped there. Now, how many segments are there? Two segments. So segments, if you see, code segment, data segment. All right. So actually, this is similar to code section only. That's why I am saying that it's a part of code section. Or if you count, it's a fourth section, separate section. Okay. So that is not important whether you're counting separate or saying part of code section. That is not important because it is same as a code section, same as code section. So where these global variables are created, this one, okay, code section, in the code section or in a portion that is called as global or static variable. So that is for global and static variable. So this is created. Now next point, when they are created. See, the variables of function are created when the function is called. Variable of main are created when the main is called. Then when the variable G is created. No. Loading time. When the code came here, loading time. That time only variables are also created. Global variables are created at loading time. So once again, let us have a glance. Loading time is which time? Static or dynamic? Static. Static. So loading time is static. So indirectly we say compile time. That's the general answer we get from academic student. So loading time is static. Static means compile time. So actually it's not always compile time. Different times are there. Now you can clearly say it's loading time. Okay. So you can finish this one. Variables declared outside are global. They are visible in all the functions and they remain throughout the lifetime of a program. And they are created inside the code section, part of code section that is called as static and global variable section. And they are created at loading time. Before the program starts, they are there. Means not at runtime, before runtime, at loading time. So before program starts, they are there. Whatever is written on the board right now, is it static or dynamic? Dynamic. Tomorrow it will change. Whatever is there in notes now is dynamic because class is running. Whatever is happening at the running time of a class, it's dynamic. When the board was fixed in the classroom, static. Static. At the class construction time or whatever it may be. Now, when this session was started, before the class started, before the class. So that was a loading time, you can say. So like this, you can take the difference. So this is a part of code section. Any questions from online students? Okay, this is over. Huh. Lokesh, I have answered your question. 5, 6, 7. Very good, Deepak. Move next. Is it okay? Uh-huh. Name value is dynamic. Value, name, so many things are there. We are talking about it address. Address is created at loading time. That's how that part is static. That's why they have used the word static there. Now, we have to talk about static variables, right? Global, I have explained. From the storage classes, auto means if you don't say anything, it's auto. Extern, if you declare outside, they are already extern, right? And register, I said that if you say register, they will be created inside CPU register if registers are free. Otherwise, normal variable. Same as auto variable. So if it is inside register, that will be faster. Okay, that will be faster. Now, static, we have to learn about this one. Okay, and global or static variables are used in a lot of gate questions. Many gate questions are there. Global variable is declared, static variable is given, and the code is given using these. Now, what is the output? So if you miss that, or if you don't know how it is working, or you don't know the working of that static variable, then you may give wrong answer. So many questions are there. So static, the important thing we will see. See, I'll write down a code here. Follow this. You don't have to copy, just follow this. I'm explaining you static. I have a function fun, and this is having a variable O. This is having a variable A having value 5. Then A plus plus print A. This is a main function. And from this, I will call function fun. I will call function fun. I will call function fun. What happens? Let us see. When the function is called, okay, let us start from main. When the function fun is called, a is created, have value 5, a plus plus, it becomes 6, and 6 is printed. Here it is printed. So actually we call from here now. So let us show 6 here. Then function ends, a is destroyed. Finish, deleted. Again come back to main function. Next line. Again the function is called. So again a is created, value is 5, a plus plus 6, and printed. So let us say it is printed 6 here. And function ends, a is deleted from the main memory. Activation record is deleted. Now, then back to main function. Again function is called, a is created, a plus plus 6, so 6 is printed. So every time when you're calling a function, a is created, value is assigned, it is incremented and used, and again deleted. Okay, understood this one? This is happening. Now, what happens if I declare variable? Okay. Let one more thing. Can I print a here? No, there is no variable called a here. That inside main. Okay, this you know. Now watch here. What happens if I don't declare a here, if I declare a assign 5 here? Now first you tell the output. 6. No, this is not there. This is not there. Okay. Uh, this is not there. Huh. First time 6. Next time 7. Oh, sorry. Where is undo? Yeah, undo. Next time 7. Next time 8. Can I access this? Yes. So because it's a global variable. So global means it's belong to all of, actually it can be visible in all the function and stay throughout the program. And where it is created? Inside. Where it is created? Inside code section. Let us say code section only. Okay. So that's easy for us to communicate. Code section. But when you have this variable, this is created in stack and deleted every time when the function is called. So what I want is, see the requirement as a programmer. What I want is this variable should be created in code section. So means global. No. All should not see this variable. Only this function should see this variable. Whenever I call this function, only this function should access this one. All right. So I should write on what? Static. In a hotel, if you enter, all tables are there. You can sit on any table. Public tables. You can sit anywhere. But one table is reserved. Only that person will come and use the table. Where it is kept? In public place. But it is made as reserve means private. Reserve means private. Kept in public place, but it is reserve means private. So it is just like that only or not? Where this will be created? Code section. How long it will be there in the main memory? Throughout the program. And when it is created? No, when it's created, loading time. But who can access? Only that function can access. Right? So now, if you write like this, what happens? First time 5 is created. Am I right? First time 5 is created. Loading time only 5 was created. First time it's not created. Loading time only it was created. So when you call function, it comes as static now. Yeah, it's already there. It will not create. Loading time it is created now. So it will not create. So just it will say plus plus. So it becomes how much? 6 and print. 6 is printed. Then again function ends. It is not destroyed because it's not in the activation record. It's not destroyed. Again the function is called static. Now it's already there. It's not created. But what was the value? Just now it was 6. Now it will make it as 7. 7 and print. So at that time 7 is printed. Again the function ends, it's not in activation record, it's not deleted. Again the function is called static. Now okay, it was created at loading time, I don't have to do anything. So it's going to the line but not doing anything because that line was executed at loading time only. One time only, it was created at loading time, not at the calling time at all. So this line is not executed at calling time at all. All right. Compiler will change this code in a such a way that for this line, at the loading time, the memory is allocated. And it's not inside the function. When the function is called, that machine instruction is not inside the function. We wrote here, but compiler will keep it somewhere else. Okay. So it will come here. The very first line is x plus s. So it becomes how much? 8 and print 8. So I am showing in this line. Can you access this? No, you cannot access. Not access this because it belongs to only function fun. So these are static variables. Okay. So this, if you want to note down, you can note down. So what are the points? These static variables are created. Oh, I'll do one thing. Clone, move to this slide, move. What is this? Acha, it's copying over that one only, I think. Okay, leave it. Anyway, so they are created inside code section here. Here they are created, variable A. At what time it is created? At loading time, loading time. Acha, see, 5 was there, function gone. Again function came. Sorry, 5 was there. Just listen, just listen. 5 was there. It became 6. Function made it 6 and function gone. After some time, again the function was called. So it saw it as 6 and made it 7 and function gone. Again after, here quickly I am calling it, but in the program after some time again the function is called. Again it visited there. So okay, it is 7 plus plus 8 gone. So function is coming and going, but the value is remaining as it is, as a history. So this property is called as history sensitive. History sensitive. This is called as history sensitive. Static variables are history sensitive. हर जन्म में वो क्या वैल्यू लिख के जा रहा है वो वैसा ही रह रही है. इस जन्म में आया 5 को 6 बना के गया, नेक्स्ट जन्म में आया 7 बना के गया. In every life it is coming and changing the value, and the values remain as it is as a history. So that's how it is history sensitive. Okay. Static variables are history sensitive. So you can make a new note of this one if you want. So they are created at loading time, and they are not created when the function is called. They are not created at function is called. So that's all. We stop here. We have to start recursion. Actually, last time I have started recursion, explain you the recursion and stopped. But we will do programming now. Now we know about data types, we know about scoping, we know about static variable, we know these basics. Now we'll mix and write on a lot of programs. And the way I'll be teaching you is, I'll write on the gate question. You'll answer the question. How? And you will give a correct answer. But whenever I say you will give wrong answer, that time only you'll give wrong answer. Okay? Most of the time you will be giving correct answer. I'll show you the gate question after the topic itself or during the topic itself, and you will give correct answer. So how it is possible that you give correct answer? Because you know all the concepts beforehand. That's my approach. Instead of taking a question and explaining you all the details of that, already you know the details, you see the question, you give the answer. That's the approach we are taking. So that's the reason till now we have not seen a exact single gate question. Okay. So it will come next class onwards, it will come. So see you tomorrow. Any questions from online students? Yeah. So Kusuma was answering. Deepak was answering. Okay, that's great. So next section, next class onwards. Yeah, sorry to I did not. I was told that there will be online students, but I was not aware how to check the online messages and all. And even we got a faced a power failure here. That's why that mic was not working properly in the beginning. But you have not missed anything. Don't worry. You have not missed anything. नहीं नहीं है, नहीं नहीं है, नहीं है. कैसे करना है? नहीं पता.